All right. We still have to solve. This is inverse function part 6, video part 6. I still want to solve number 2, 3, 4, and 5, and two more extra questions before I finish this section. And but I will just prefer to start with number 5. It is very important question, and it show us a good idea about every single detail to discuss in the we need to discuss in the inverse function. I think so one video for this is not enough, especially I talk too much maybe. All right, so let's start. Not wasting time. F of x equal x cubed minus x, where x belongs to 1 3, right? All right. First, prove that the inverse function of f exists. We need to find if we need to know if f inverse of x exists, right? And find its domain and range, as usual, as we did as usual. So let's start part A. Part A. Okay. First, what is domain of definition of this function, which is f of x? Domain of definition is all sub r from minus infinity to plus infinity, and we have it since it is since it is a polynomial function, then it is defined and continuous over all r. This means it's defined and continuous over 1 3. So continuity is all right. So f is continuous, defined and continuous over 1 3. For sure, it's defined and continuous. Defined and continuous. Then we check for the derivative, right? To see if the derivative monotonic, right? What is the derivative of this function? F prime of x equal derivative of x cubed is 3x squared minus derivative of x is equal to 1. All right. Let's see if this function is increasing function. If 3x squared minus 1 is increasing function. All right. Over what? Over 1 3. We can substitute, right? 1. It will be, since it's x squared, I prefer to do it this way. Just be careful. X is a function, x is a, by definition, it's included between 1 and 3. This is easier for you. Okay? Square them all. If we square them all, we don't change the sign, right? Why we square them? Because I need to have x squared. I need to have x squared. Actually, I need to have 3x squared, so let us multiply all of them by 3. 3, since it's positive number, so never change the sign. Okay? I need to subtract 1. This will be 2. This will be 3x squared minus 1, and this will be 8. So it's a function included between 2 and 8. So it is what? It is always positive. 3x squared minus 1, it's always positive. Then the function f is strictly increasing, so it's monotonic. So f inverse exists. F inverse exists. This is the first part. Second part B, find the equations of the tangents at the endpoints of the curve of f. We have endpoints. Before I do that, sorry, we forgot to do the domain and the range of f inverse, right? X cubed minus x at 1 3. X cubed f of x is x cubed minus x at over 1 3. All right, so what is f of 1? F of 1 is equal to 1 minus 1, then it is 0. F of 3, it's 3 cubed 27 minus 3, it's 26. So can we say that f has domain 1 3 by given, and it goes to the range 0 26, right? And f inverse has domain 0 26, and it goes to 1 3 not 13, 1 3 as range. Now, where are the I think so I did something wrong here. It's not 26, it should be 24, right? 27 minus 3 is 24. I do a lot of these mistakes, calculation mistakes, so follow me and don't panic. Just correct what I do wrong sometimes, right? Now, can we say that point A has abscissa 1, ordinate 0, and point B has abscissa 3 and ordinate 24 are the endpoints? For sure they are endpoints, okay? Endpoints, abscissa gives me ordinate 0, ordinate 24. So 1, 0, 3, 24 are the endpoints. Okay, what is the derivative at this endpoint, at 1? We found the derivative. It's a 3x squared minus 1. So it's a 3, 1 squared minus 1. So it's equal to 3 minus 1. It's equal to 2. All right. The derivative is equal to 2. He said find the tangents at these endpoints. Tangents, we all know this is the tangent one because we have two endpoints. It's y minus y node equals slope, right, into x minus x node. All right, y is y. X is x, right? The minus y node is, I'm finding the tangent at this point, a, 1, 0. So y node is 0. It's ordinate of a. And abscissa of a is 1. What is the slope? The slope is always the derivative at the point. And I just found it here. F prime at 1. So it's 2. So one of the tangents is y equal 2x minus 2. This is tangent 1. All right? Let's go and find tangent 2. To find tangent 2, for sure, we need to find the slope at the second point, which is B3, 24, right? The f prime at abscissa 3 is 3 into x squared minus 1 in the derivative, remember. So it's 27 minus 1, it's 28. I did it correct this time. Okay, so tangent 2 is y minus y node, which is 24 this time. I'm finding the point, the tangent at point B, is equal to 28 into x minus 3. So y equal 28x minus 28 times 3 plus 24. I guess it will be minus 54. Okay, you can check it if it is true, if it is wrong. You correct it. All right. Now we did that. We still have like 3 minutes, a little bit less. Let's see if we can find. We found, okay, we did part A, we did part B. Now find the coordinates of point of intersection between the curve and y equal x. This is the most interested and important point we have before drawing. It helped us. What was the equation of the function? It was x cubed minus x. And let's see if there is point of intersection between this function and y equal x, which is the first bisector, equation of first bisector. Y of the curve should be equal y of x to find the point of intersection. This means x cubed minus x equal to x. This means, by other words, x cubed minus 2x, taking this x to the same side, is equal to 0. So x into x squared minus 2 is equal to 0, right? We have 3 points here, 3 points of intersection. Let's see if this is correct. So this is x equals 0. If we take it equal 0 to make all the whole product equal to 0, this is a rejected point. Why it is rejected? Because our domain is 1, 3. So it's out of our domain. The other one, x squared minus 2 equals 0. It gives me that x squared equal 2. This means x equal either plus radical 2 or x equal minus radical 2. Also this out of the domain, so also it's rejected. So the only accepted point is x equal radical 2. Remember, if x equal radical 2, this means y equal radical 2. By substituting it here, it's easier than substituting it for sure in the first function. So the point C, let's say, it's radical 2 abscissa, radical 2 ordinate. It is the point of intersection between the curve and the straight line y equal x. Now we can simply draw. We can simply draw. Let's draw our function. Okay, let's draw the function. This is the ordinate axis, and this is the abscissa axis, right? And we still have time. No, we don't have time. So I will finish this problem, this very important problem, in the other part. Okay, don't forget, you should draw the y equal x, which is only this part. We don't need that part, but let us draw it. Okay, this part is y equal x. Okay, It's not